Hi students, MCQ number 11. A conducting sphere of radius r carrying a charge capital Q is joined to an uncharged conducting sphere of radius 2r. The charge flowing between them will be. Very interesting numerical problem. Now you can see two spheres. The first one is having a radius of r and it is holding a charge capital Q. The second sphere is having radius 2r and it has no charge. Now both are joined with the help of a connecting wire. So you can see here I take a connecting wire and I join. Okay. So what is going to happen? The charge from the sphere A will flow towards the sphere B to some extent. A few quantity of charge will flow from the first sphere to the second sphere. So after joining, let Q1 coulomb be the charge in the first sphere and Q2 coulomb be the charge in the second sphere. So now both the spheres are joined together and it forms a single system. Before joining with each other, these two spheres behaved as two different systems. So in a single system, joining the two spheres, how much charges will flow from the first sphere to the second sphere? That is, we have to find the value of Q2 coulomb. What is the value of Q2? We have to find out. Before that, my dear students, you should know that when a wire joins the two spheres, the potential at any point on the surface of the first sphere and the surface of the second sphere will be the same. So V1 is the potential at any point on the surface of the first sphere and that will be equal to V2, which is the potential at any point on the surface of the second sphere. So I will write K, that is 1 by 4 pi epsilon naught K into Q1 divided by the distance R1 must be equal to K into Q2 divided by the distance 2R. So instead of R1 I will substitute R, instead of R2 I will substitute the 2R. Okay. So now this K and R get cancelled on both sides. So Q1 is equal to Q2 divided by 2 or Q2 is equal to twice Q1. So this is an expression which is required. Are you understanding? So how much charge has flown to the second sphere, that is Q2. Okay, now you see here the total charge in this system before joining was Q plus 0, that is Q. So after joining also, by the conservation of electric charge, the total charge should remain constant. Therefore, Q1 plus Q2 must be equal to capital Q. Okay. So Q1 plus Q2 is equal to how much times Q1? 2Q1. So this is 2Q1. So this must be equal to capital Q. So totally 3Q1. So 3 times Q1 is equal to capital Q. Therefore, Q1 must be equal to Q by 3. So this is equal to Q by 3. So this is our next step of understanding. So we have found that Q1 remaining in the first sphere still is equal to what? Q divided by 3. Therefore Q2 is equal to 2 into Q1. So this is equal to 2Q divided by 3. Okay, that is the final answer. So how much charge has flown? What is the question? The charge flowing between them. Between them means from the first sphere to the second sphere, how much charges are flowing? That must be equal to what? Q2 is equal to 2 times Q by 3. So this is the final answer. Okay. So which option is correct? Option C is the correct answer. Okay. Therefore, option C is the correct answer. Okay, I hope you must have understood well. Fine.